So, relational data model. First of all, that sounds quite mathematical. Relations, yeah, relations are a mathematical object, yeah, and that might be a little bit intimidating at first sight, but relational data model is nothing else but tabular data, and that's good news because all of you know tables, and this kind of structure is well understood by you, and therefore forms an easy to understand basis for the following. But nevertheless, we need some technical terms in order to talk about the relational data model, and this is what the slides here are going to provide. So first of all, if we talk about relational data, we have to distinguish two levels, namely the schema level and the contents level. And this is these are two different things. The schema level tells you about the structure of the table, how the table is built. You could also call it talks about the type of the table. And the context, these are the real records that are stored within the table. And if we look at this specific example here, we already see the elements, yeah, of a table, the schema as well as of the contents. So let's first concentrate on the schema. So by the way, if you have any questions, or if I am too fast, just interrupt me and directly ask a question. Yeah, that's perfectly okay, of course. And actually, I also enjoy it to have a little bit of interaction here. It's makes the lecture a little bit more living, more vivid, and more interesting. So okay, let's first concentrate on the schema, and the elements of the schema. First of all, is the table name, and the table name, of course, should be well chosen. It should describe the contents very well. And what does it mean? It should concentrate on one singular concept. Yeah, I will come to that later on. I will discuss it a little bit more deeply. But the general idea is that you, for example, should not mix data of different concepts. For example, you have data about students, and you might have data about lectures, and this information should not be mixed within one table, but it is really important that tables concentrate on one singular concept. And if the table name is student, we only should have information within that table that is directly related to that concept. And if we have the table name, of course, we also need column names. Yeah, the column names here. So we have several column names. For example, we have the name of the student, and we have a first name, and we have immatriculation semester, for example, and we have a exmatriculation date. Yeah, this is a date when you leave, when you have finished with your studies. Yeah, and of course, most entries within the table should have a null value in that, because all those records that have a real value in it are not longer part here of the study and so on. Yeah, so you see that columns might be empty, for example. Yeah. And we have the matriculation number. It's also a column. And then there's a specific column here that I have called it SID for student ID. So this is the usual way how I talk about such kind, how I name such kind of columns, namely so-called primary key columns. What do you think is the idea behind a primary key column?
Is to be able to, yeah, go ahead. Sorry.
It addresses both to the horizontal, like the columns and the rows both. So.
Yes, but if I take, yeah, that's okay. But if I, so what condition should hold for the primary key? Yeah?
Primary key, it is like a unique ID.
Yeah,
That particular table.
it should be unique. Yeah, it should be unique ID that identifies. And what does it identify? The record. And that's where we have the connection to the contents. Each row within one table is called a record. And there are different names for that. Records could also be called instances of students or objects, because the idea is that one record contains the information of one specific object. In this case here of students, yeah. So or of one specific instance. Yeah, depends if you would like to call it object or not. But if we have rooms, we might better call it object, and otherwise, if it is persons, we might call it instances. But it doesn't matter. Actually, all three terms, records, instances, contents, objects, could be used in the same way. Yeah, as they are aliases, and sometimes also called a tuple. Yeah, if you look in a more mathematical representation of the relational data model, such a record is also called a tuple. Yeah, and the primary key is something that must be unique, and the important point is that the database systems, if I try to insert a new record with a primary key value that is already available, the database system would reject that. Yeah, and this is an important step in order to provide consistency, consistency of your data set. The database system takes place, keeps tracks of that. Yeah. If you look at the matriculation number, if you take a closer look at that, we also notice that also is unique. Yeah, and that might raise the question: couldn't we use matriculation number as a primary key instead of this anonymous student ID number? And the answer is yes, we could do that. That would be possible. Yeah. And later on in different slides, I will use that in that way. But here in the beginning, I would like to discuss one important aspect from a practical point of view. The general rule of thumb is that meaningful columns that have a meaning should not be taken as a primary key, even if they are unique, because meaning might change within the lifetime of data, within the lifetime of the data within the table. And if you add an additional column where you have a total generated number that is not connected here to that meaning here, for example, later on, matriculation numbers might be extended for whatever reason. So not only 6-digit, but 7-digit, yeah, or whatever, of some further information is encoded in that. And then the primary key is changed. And changing a primary key in an active database is usually hard to carry out. I'm not going into the technical details why that is the case. You just have to trust me that is that way, yeah, that it is that way. So therefore, usually tables should have an anonymous column. Yeah, if you should be in the situation where you have to design a table that should be stored within a database, that it's not so probable, I would assume, but if, then please remember, take an anonymous primary key. Yeah. So one thing that that I haven't explained yet is the topic of data types. And so if we look at name and first name, of course, the data type is quite obvious, namely that's of type string. Yeah. What do you think xdate? What is it also of type string? Looks like a string here. What do you think?
It's number, miss.
It's
What I
number.
see in the string we have there. Yeah.
Yeah.
Yes, we have in the string first name as a name, letters, but here in the date we have the data of number.
Yeah. So actually we have numbers that are separated by slashes here. Yeah. But that's not the way how we should look at it.
Like integers
Yeah.
and characters.
Yeah, sir, I think yes, it's a string, string of characters. Like any sequence of characters is string, so it can be considered as a string.
Okay.
I think computer stores it as a number because there is a starting date for which they have stored at 00, and from that they calculate that it is the exact date from it.
Yeah. So you assume that the whole thing is converted into a number.
Yeah.
Okay. So the answer is neither the string nor number, but it is of type. It is actually of type date. And the important distinction is what you see here actually is only a representation. So if I provide that date in German, it would look different, but it would be the same date, of course. And the point is, within the database, so the internal representation is actually a date, and this has a specific consequence. Namely, if it would be a string, you could insert every kind of string. Yeah, you could, for example, insert 2019 06 31 31. That would, from a syntactical point of view, that would be okay, but there is no June 31. It's only 30, the largest day within June. Yeah, and if it is really of type date within the database keeps track of that. And if you try to insert a wrong date, so providing a string that doesn't represent a valid date, it would reject it, and it would go even so far that it also would handle split years, for example. So usually you have there are some years where you have 29th of February, but that's only every 4 years. Yeah, sometimes you could for some years you could enter 29th of February, but in most years not. Yeah. And this is what the database system keeps track of. Internally, it really is of kind date. And I think you understand that this really is important in order to support consistency. And that's one major aspect of database systems, why you would store data in database systems, for example, in contrast to storing things in Excel. Namely, that the database system could keep track of consistency. And that's an advantage that is not to be underestimated. Yeah. Okay, so I would say now everything.
Professor,
Yeah.
sorry to interrupt you.
But no problem, just do it.
So in the data types, we have number, string, and date. Do we have any other type apart from these three?
Yeah, the good question. These are the most prevalent ones, the most prominent ones. Each database system has a lot of other ones. For example, decimal numbers, yeah, with fractions. But you could also have here pictures and so on. Yeah, there could be a whole range of different. You could have geo coordinates, yeah, spatial data. All kinds of columns are available, and the concrete set of columns depends on the specific database system. So I'm in this course here. I'm only dealing with the one that all the database systems provide. Yeah, but for example, for strings, you could have nationalized strings. Yeah, and strings without national information, without location information. So all kinds of things, all kind of difference are available there. Yeah, but good question. Thank you. Yeah, if we look at the records, we have the column name, for example, first name, and if we talk about the column, then we are talking about the contents. We have column name that's on the schema level, and we have the column that's on the data level, on the contents level. Any further questions here with respect to that slide?
Professor, like how do we define primary key? Like, is it any solid reason to define certain column as a primary key?
Sorry, can you repeat it? I didn't got it.
Yeah. So how do we define like primary key? Like which column should be primary key?
Yeah. So my suggestion is take an additional column that is not part. So it's neither matriculation number nor name nor first name, something like that. Just provide an additional column and call it something ID with ID at the end. Yeah.
Yeah. Okay. Thank you.
It's on top. Yeah, it's just on top. Of course, you could use matriculation number as I've explained, but my advice would be take an additional one, call it something with the end ID, for example, SID. Yeah, I'm using the first letter usually of the table, and then it's it. Any further questions? Okay, then let's go ahead. What we have seen on the previous slide is the so-called tabular representation of tabular data. It sounds a little bit strange, yeah, but we're talking about tabular data and have, as it is represented here, it's called the tabular representation. The reason is there are other representations. For example, the structure representation, and for example, the code representation as a so-called SQL statement. So let's first turn our attention to the structure representation here on the left-hand side. So that looks quite similar. We have the table name. We have a box, a rectangular box here. Yeah. Also, the tabular form is a rectangular box, but and on the top, at the top, we have the student name here. Yeah. But now the columns are not arranged horizontally as it is done here, but they are arranged in a vertical manner, and we don't see any data in that representation. We just see the structure. The reason behind that is the tabular representation is nice if you have few tables that you have to look at, and if you have few data records. But as soon as if you have thousands of records, of course, that wouldn't be possible to represent it that way. Of course, also having the real data within the presentation, that takes a lot of space. And the point is, if you have a larger data model consisting of many tables and you would like to get an overview, then you might want to concentrate on the structure and you would like to disregard the data for a moment. And then the structural representation is the best one. So this is the representation that you're usually going to use if you are dealing with larger data models. Yeah, and actually we will use both kinds. We will use the tabular representation as well as the structural representation. And for example, if the names of the columns are clear, then the structural representation is usually sufficient. But as soon as the table, the column name is not quite clear, you might like to revert to concrete data in order to get a better understanding. So a combination of both representations often is used in order to get a complete understanding. Yeah. The third kind of representation, the SQL statement, that is necessary in order to implement the relational data model within a relational database system. This is code. And of course, code must be much more detailed and much more precise than the graphical representation. And this is something you immediately see here. Yeah? You see, for example, that we not only have the name of the column, as we have it here, but also the column type must be given. And then there's something that's called not null. That's a so-called not null constraint. And that tells you that that column must have values. So you are not allowed to insert a record without a primary key, to insert a record without a matriculation number, and so on. The only column that might be empty, that is allowed to be empty, and you see there is no not null constraint here, is the X date, because that must you must have the possibility to have it, to leave it open. Yeah. And for example, with respect to first name and last name, you not only see that's of kind string, and this is a SQL way to talk about strings. That's variable characters, varchar. That means a string of characters of variable length with a maximum length of 50 in this case. So the number here is the maximum number of characters, the maximum length that column could have. Now, if you try to insert a name that's longer than 50 characters, the database system depends on the specific system. Either it might reject it or it might truncate it. Yeah. So date, and here you see date. Yeah, that's a type name, as well as integer, as well as varchar. These are the type names. Yeah. So these are the different representations. The ones we will encounter most of the time is the tabular representation as well as the structural representation. Maybe at one or the other time I will also show you some SQL code to create a statement, but SQL we will use SQL mainly in order to construct queries.
Professor,
Yeah.
in the previous slide where that SQL statement is there, we have written a name in front of name, that varchar. So that varchar will always constitute of letters, or they might have some different characters such as @ or something like that.
Yeah. So characters.
Or any other database, not for the name, but let's say if we have any mixture of letters and other symbols.
Yeah. So the data type varchar comprises letters as well as digits, as well as special punctuations, signs, and all kind of characters that are available within the character set on the computer.
Okay, thank you.
Okay, now, of course, we do not only have, usually we do not have only one table within our database, but many tables. And of course, we would like to relate information between different tables. Yeah. First of all, remembering the general idea that one table should only represent one concept, we immediately see that the department, because it has a name and it has a location, for example, is a concept that has to be differentiated from the concept of student, and therefore it makes perfectly sense to have two different tables, one for students, one for department. Yeah. In an Excel sheet, usually you would combine that information. You would have one student table, and you would put in the name of the department and the name of the department location in the same Excel sheet. Yeah, but this is, and we will discuss that later on, that this is problematic from a data integrity point of view, and within relational data models that should definitely be avoided. Yeah. So having now two tables, student and department, and having a connection between those two is, of course, because students are within departments, enrolled within departments, this kind of connection is called a foreign key. Yeah, so this is the technical term for that, a foreign key from one table to the other one. And if you look at my slide, I now have provided the structural representation as well as the tabular representation here on one slide. Yeah, because it helps us to discuss the concept. So first of all, taking a look here at the structural representation on the top on the top of the slide, I have added a further column here within the student table. I've called it dept. Yeah, that is a column that is related to the primary key column of the target table, which in this case is department. And the primary key of the department table, I've called it DID, and the foreign key here that must not have the same name. It could have any name, and on this arrow here that is depicting here the relationship between those two tables, I give the information which columns are connected. Yeah, dept equals DID. That means the department column is pointing to the DID column. So the foreign key column department is pointing to the primary key column in the department table, which is called DID. Yeah. So in having this graphical representation, you immediately see how things are connected. So now let's take a closer look what a foreign key actually means. And let me ask you one question. The primary key must be unique. Must also a foreign key be unique? What do you think?
No.
No.
Yes, I think.
So somebody says no, others says yes, sorry. What is right?
Unique for the department column.
Yes, the sub column, the sub information of that.
Okay, so the question was, must the foreign key be unique or not? So there are different opinions on that. But if you look at that column, at that real data here, you immediately can answer the question if it must be unique or not.
No, it should not be.
It must not be unique. Because you see, there are two records here that have the same value. Of course, the DID, the primary key, must be unique here. But the foreign key, the name of foreign key is a little bit misleading because it's also called key, yeah, and it might suggest that it also must be unique, but this is not the case, yeah. And why is that the case? Because many students could be related to the same department. So if you look here, student number 1 here and student number 2, both of them are registered in the MBAE program, and you see it via following the path of the foreign key. So the foreign key depth of record number 1 here has the value 1, and the primary key that is corresponding to that, number 1 in the department table, refers to the MBE department. So both of them are in the MBE department, and here the last one here is in business computing. Yeah, and that's important, an important property of a foreign key, namely that it constitutes a so-called one-to-many relationship. So we are talking about a one-to-many relationship, and it is read as follows. Each department could have many students, and each student is related to one department. Why is it the case? Because if I take one student record, I only have one slot, namely the department slot here in that student record, where I can put that number in. And in the relational data model, you can only have one value within a column. So there could only be one number. There could not be many numbers. Could only be one, because it's of that data type integer, and the property of the or requirement of the relational data model is that columns must be atomic. That's also something that's different within Excel. That you can have a list of numbers, for example, could provide a list of numbers in Excel, but we will say later on that comes with a price. In a real relational data based system, in the relational data model, we have the restriction that columns must be atomic. That means for each student record, we can have only one department number, and that immediately tells you that each student can only belong to one department, not too many. Yeah, that's modeled here. For example, if you were in a university where a student could be enrolled in many departments, this would, for that university, it would be a wrong data model. So that's also an important aspect of data modeling. Data models should capture the reality of the specific area it's talking about. And for example, at the HTW, you can only be enrolled in one department, and therefore for HTW that would be okay. But for a different university, it might not be okay. So the correctness of a data model is not a general property, but it depends on your domain, on your business domain. Yeah, so you always have to look at the business domain. Then you do data modeling, and then you have to check if your model is correct with respect to the domain, and that this is usually done in the requirements engineering phase if you are building such kind of system. Yeah. But actually, this is not within that course. These kinds of questions are not so much our concern here. But during the introduction of the relational data model, of course, I would like to mention that aspect here. Yeah. But on the other hand, since that different records might refer to the same, since this column is not obliged to be unique, there could be different records with the same foreign key value, and that means different students' record point to the same department, and therefore a department could have many students. Yeah. So this is at the beginning. Usually, the foreign key is not so much an easy concept for you. Yeah. The previous semesters have shown that usually takes some time to grasp the conceptual idea of foreign keys, but that is how they are working. Yeah. Any further questions here to the
Professor?
Yeah.
We just discussed that if we take the example of our college, so one student belong to the one department, so that's the That's why we are using a foreign key. But let's say if we have one student belong to two departments, then do we need to give two foreign keys, or means
No, we need a different solution, and I will show you later on how to
Okay.
do that, because if a student could belong to many departments and each department could have many students, we would have what is called a many-to-many relationship. Yeah, and we will later on see how to model many-to-many relationships.
Okay.
So from a conceptual point of view, yeah, we can distinguish one-to-one relationship, one-to-many, many-to-one, and many-to-many relationships. Yeah.
Yeah, Professor, like in addition to Sanket's question, like normally in one table there should be one primary key, but how like foreign keys should be multiple? Can we use multiple foreign keys, or just it should also be one?
Actually, so first of all, a table could have many foreign keys, and we will see examples of that. But a table could also have a foreign key that consists of many columns. That also is possible. I have not shown it here at the beginning because it's a more complex situation, but we will see examples later on also on that. Yeah. But if we have a primary key that consists of many columns, it nevertheless is one singular primary key. And that's different because we could have many, actually really many foreign keys within one table. So to answer your question, yes, a table could have many foreign keys.
Okay, thank you, Professor.
Further remarks or question? Okay, yeah. So let's take a more closer look at data types. So we have, for example, numerical data types. We have already seen an example of that, namely integral numbers, integers. But we could also have decimals. For example, a decimal 5,3 means that we have a fixed precision numbers that has 5 digits and three digits in the scale. Yeah. So be behind the comma here. And we also have floating point numbers. They are also fractional numbers. Has anybody of you an idea what is the difference between fixed precision fractional numbers and floating point fractional numbers? Why they are there? That's not so easy to answer, of course. Yeah.
In fixed precision numbers, we limit the numbers that can come after the decimal, so that maybe to increase the computational speed as well as reduce the complexity. But in float, we don't do that to increase the accuracy of the result maybe, but it requires considerably more amount of computational power to do that.
Yeah, that's exactly the point. These fixed precision numbers, they are usually used in the business context. For example, currency amounts. Yeah, and they should have within a general ledger also. They must have a fixed precision. But if we are talking about information about technical processes or something like that, for example, if we are measuring temperature, we are measuring weight or height of persons, there usually floats are used. Yeah, and they could be calculated more efficiently and so on. So for technical information, floats are usually used, and for business-oriented information, yeah, usually decimals. So actually for us, I would say decimals are usually the ones that we should use. So the string data types, there are fixed length strings and variable length strings. Yeah. So the variable length strings we have already encountered. So if I have a varchar 3 and I insert the string db, then only the 2 letters here would be stored. Yeah. And maximum would be 3 letters that would be allowed. But if I store the same sequence of letters db here within the char3 record, then it would be filled in order to have that fixed length, and it's up to the database system how it gets filled, and usually it gets filled with blanks or something like that, and it also depends on the database system at the filling appears at the end or at the beginning, so that is something that has to be figured out. Yeah. But for us, varchars are the ones. Yeah. I have only for completeness. I have only mentioned them for completeness sake here. But often, so for example, if you have currency notations or look here, location notations for countries or so, yeah, or for languages, the EN or something like that, they have 2 letters, then you might have a char2 or something like that. Yeah. And last but not least, we have the date and time data types, and usually database system quite diverse on handling that, unfortunately. For example, if I have a column of type date within the Oracle database we are going to use, it comprises date as well as time. Now, even though in the previous slides we only have seen the date part, yeah, that's matter of representation, but the date also comprises usually time. And if you only insert, for example, the date part of a date value, then the time is 00:00:00:00. Yeah, it's usually filled with zeros, yeah. But it could have a real time value as you see it here. Other database system might represent it differently. They might have a time data type, and the date column, the date type only comprises dates without times, and the time only times without dates. That depends on the system. Yeah. Okay. Oracle, date and time together. Any questions here to the data types? That seems not to be the case. Then let's talk about integrity constraints. I already have mentioned that one of the main advantages of using a relational database system or a database system in general is consistency or integrity. Yeah, and consistency and integrity is more or less the same. So for our reasons, it's the same. The database system helps because it tries to avoid inconsistent values in order to reject, for example, by rejecting inserts that are not correct. And up to now, we have seen the following, more or less the following constraint. We have seen the primary key constraint. We have seen the primary key, and together with the primary key comes the uniqueness constraint. The primary key means uniqueness, and as we have already discussed, it's identification of record. But there's also something that's called a unique constraint. And if you look back here at the matriculation number, we could do the following. We could say, please put a unique constraint on matriculation number. Then matriculation number still is not a primary key because it is some kind of technical thing, yeah. But nevertheless, the system would check if the values here are unique. And of course, that is something we would like to have, that matriculation numbers are also unique, and the database system can check that. Yeah, that's really an advantage to have unique constraints besides primary keys. So we can have it. We can have both the anonymous technical primary key and a contentful unique column, and both are checked. Second thing is foreign key. Foreign key depicts the relationship, or it shows us the relationship between tables, and what is connected with that is called referential integrity, and that's That means the target must exist. So let's switch back here to the slide. Assume I would like to insert a record here, number 4, and I would give it the department number 9. And number 9 definitely is not existing here. Then the database system would reject it. It will not allow you to insert that. And that means referential integrity. All references that are here, foreign keys could be regarded as references, must exist in the target table. Yeah. And the second thing that I haven't forgot to mention is the data type must be the same. So even though the department table is called MBEE, we don't have the string MBEE here in the foreign key, but the number that is the primary key of that. Yeah, that is something important you have to remember. Foreign keys are not the descriptive values, but are the primary keys, and usually primary keys are numbers. So that's the foreign key. The check constraint is something that we haven't encountered yet. It allows you to provide restriction on column values. So let's assume we have a table for line items of orders. So you can order 1 line item or 2 or 3, but it doesn't make sense to order 0 things. Then you will not have that item on your order. Yeah. So line items must be greater than 0, but the data type integer also allows 0 and also allows negative values. So it would be nice if you could simply require have an equation that tells us quantity must be greater than 0, quantity greater sign 0, for example. And that is something that the database system allows to provide check constraints. And last but not least, they're not null constraints. They are there in order to disallow empty cells, empty columns. Yeah. So that's quite a lot here. What already is available, yeah, for using a database system. So now let's discuss a little bit this null values topic. So once again, switch back here. We have this MX matriculation date here, yeah. And if a column has no value, we call it a null value, yeah. Null value is actually no value. It sounds a little bit like a contradiction, yeah, but that is how it is called. Null value means no value. And important to understand is null value does not mean the empty string or the number 0. It means the absence of a value. That's important. Null values means absence of values. And what are reasons for that? For example, the information is not provided. Yeah, let's assume you have a form where you register, for example, on the internet, yeah, and you get a web page with a form, and you can insert your private telephone number, but that is not required. Then of course you usually wouldn't do that, yeah. And then this information is simply not provided, and therefore that column where the customers, for example, are stored, that the private telephone number must be allowed to be empty. Or the information is not existing yet. That is the exmatriculation date exists not yet for you, for example. Yeah, hopefully, and is only available after exmatriculation. Or there's a third situation. The column is not suitable. It is a little bit more complicated. Assume we have a table for persons. So we have modeled a table for the concept persons, but we have different subconcepts like students and other persons, for example, professors or other people, other employees of the university. Yeah. So the column matriculation number might only be suitable for students and not for the other ones. But since we also store records for the other ones in the same person table, matriculation number must be able to be empty. Huh?